All right, ladies and gentlemen, you may recognize something that looks similar to this. This would be the post-test, similar to the pre-test that we did back at the beginning of this semester. Those didn't necessarily go well, but you didn't know what you knew back then now. So, we're going to take a peek through one of these, maybe a couple here, as we get ready heading towards finals to get us ready for our post-test. So, number one, we've got Michael solved the following equation incorrectly. Again, incorrectly. It's not right. Okay? Tell what the error is and solve the problem correctly. So, we start to look through what Michael did. And my suggestion is, since you have to show the correct working solution anyway, would be to look at this and say, okay, well, I'm just going to do the work now myself. So I'm going to go ahead, write this down and go, okay, well, I know when there's parentheses, I'm supposed to distribute. So let's see here. 1/2 x. 1/2 of 6 is like 6 divided by 2. Now I could do that on my calculator too if I needed, but 1/2 of 6 is 3. And I go ahead and I get that, and I go, okay. Just like in Algebra 1, I got to get my x term by itself. So I got to get the 3 out of there. And then comes the moment of truth. I look at this, and again, there's a couple of ways I could do this. Now, I know some of you automatically are going to go, I'm going to divide by 1/2, but most of you don't understand what dividing by 1/2 actually means. So my suggestion, when you see a fraction, is to multiply by its reciprocal. Because then I know that I get that right, and then I'm like, oh, 2/1 is just 2. 15 times 2 is 30. So now I can look at Michael and see what happened here. All right, so we've got the same, ooh, these aren't the same. Okay, what happened here? Oh, it looks like, I wonder if Michael forgot his parentheses normally, because I see they're here, but I notice that if he distributed, he didn't multiply the 1/2 by the 6, because we got 3 and he got 6. He did everything else right, though. So, it looks like Michael forgot to distribute the 1/2 to the 6, because we can see it right there. Yes, describing the error is a part of this. There's points involved with that. You know, not only finding his error, being able to describe it and then show it correctly is also something that's important here. So we got several points here. That's why the degree is going to be a little bit higher on that one. All right. Number 2. Solve and graph the following inequalities. Show your answer in interval notation. Okay, a couple things I got to remember here. First, when it's less than, when the arrow's pointing at my absolute value, that's an and statement. And remember, and statements are the ones where we come together in the middle. Okay, the ors go out, the ands come in. So to get to the answers, there's going to be not 1, oh no, but 2 inequalities I have to solve with an absolute value. But remember, the 2 things that are going to change with my second one, because notice that basically is the same thing. I just dropped the bars. Flip my arrow, change my sign. Now once I get here, it shouldn't be bad, because I just got to add the 3 to the other side. I've got to add the 3 to the other side. Okay? Those are my inequalities. So I don't care when you write your solution. There's a couple ways you can write this. You can either write x is less than or equal to 12 and, got to have the and in there, x is greater than or equal to -6. Or I could write x is greater than or equal to -6, but less than or equal to 12. Those say the same thing. So I'm absolutely fine with you writing it either way, whichever way you think you can remember. But I've got to get the and in there if I'm going to write it as 2 separate ones. my graphed solution, again, when I'm making my line, I can't just put the negative 6 and 12. I got to show some number sense here. So I notice they're counting by 6s, though. So maybe, well, that's not a bad idea. Now, could you count by 1s or 2s and make the lines a little bit longer, or make the, your lines a little bit smaller in there? Sure. But again, when I go to graph it, x is less than or equal to 12. Okay, less than goes left. And it's a bracket because it's or equal to. It would be a parenthesis if it was just less than. And x is greater than or equal to negative 6. Greater than means we go to the right. And they smash in the middle, just like they're supposed to. And then my interval notation, or my interval solution, remember, we always go from left to right. My leftmost point here is at negative 6. My rightmost point here is at 12. Okay, so solve the inequality, graph it, do the interval notation. We're pretty good there. So we're going to have a little smorgasbord of things, which is why we kind of get a little bit of a taste of it here again with our practice. And then 3 on the bottom, solve the following quadratic by using square roots. Okay. First job, get my x term by itself. How do I do that? I got to get the 60 out of there. Once I do that, keep working at it. Again, x squared's not alone yet. Do not take the square root yet until it is isolated. Once we have it down to where it's just x squared, now we're ready to do our square root. Because again, squared and square root are opposites. They're inverses. So they just cancel each other. But now I got 2 huge things I've got to remember. This is where a majority of the points are in this question. First of all, it's a quadratic. It's squared, which means there's how many answers? 2. So 2 answers means I do plus minus. I also notice that there's a negative under there. We don't like negatives under there. We just don't like negativity whatsoever. So how do we deal with negativity? That's right. We pull an I out. So I'm going to leave a little space there because I may have something in front there to work with that. And then finally, I look at my 12 because, again, I pulled my I out. But I got to make sure, hey, can I break down the 12? Is there a perfect square that goes into 12? And there is. We've got 4. Take the square root of those. The square root of 4 is 2. Notice that gets out of radical jail. That gets to hang out with I. But the 3 is still under the radical. That gets me to my answer. Okay, so there's bits and pieces there. But again, negative radical, take an I out. If there's a perfect square that's a factor of the number that's under there, you need to break that down. Okay? And if in doubt, mess around in the calculator with some perfect squares. Plug them in there and see which ones you can find will work. All right. Number 4. Using technology, using the calculator, find the zeros. Find the zeros. Find the x-intercepts to 2 decimal places. Okay? So we'll get our y equals up here. We're going to type in our equation. And once we have that, okay, we're going to go ahead. We're just going to graph for a minute. So here's what I'm on the lookout for. I want to figure out what that value is and what that value is. So this is where we go back through our steps. So we do our second and trace. We're looking for zeros. It says it right here. And this is the one where I start to move left or right until there's my cursor guy. So we're close to this guy. So I want to get as close as I can to the x-axis, to my 0. And then I'm going to go left, 1, 2, 3, and hit enter. That'll give me my first border here, that that little arrow. Then I go 1, 2, 3, gets me back where I started. 4, 5, 6, with an enter. And now you can notice my 0 is in between my two border points. I hit enter one more time, and we're going to 2 decimal places, so negative 2.27. The x value is my 0. Now I have one more answer. I still got to figure out this guy. So I start the process over. So second trace, down to 0. And now I'm just going to start arrowing to the right until my cursor shows back up. There he comes. That's pretty close. And again, remind yourself you do left first. 1, 2, 3. And you're like, well, wait a minute, that's under this time. It's okay. He's doing left first. I hit enter. So then I go 1, 2, 3 to get back where I started. 5, 6. And remember, it's just like anything else. We work from left to right. So now there's my borders. I'm trapping it in. That's good. I hit enter, and we end up with 5.27. That's my other one. And I've got them. But again, and just practice with these. Even if it's the same exact one you keep doing, knowing what the answer is, it's good practice. Second, trace 2, and then just trap them in there. All right, let's see what else we got here. Questions 5 and 6 use the functions. Okay, function stuff we've just been doing. Find g of x minus f of x. Be careful with the order. Okay, here's my g of x. So x squared minus 2 minus 4x minus 3. And some of you may still be wondering, again, why are you using parentheses there? Why didn't you put parentheses on the first part? I could. Okay, but it's not going to change anything like the second one. The second one, I'm subtracting this quantity. So when I subtract, it means I subtract everything. That negative goes to both sides. So nothing happens in the first part, but in the second part, my 4x is going to change signs, and my negative 3 is going to change signs. But I'm not quite done. Why? Because they're still like terms. So x squared minus 4x, there's no other x terms, but negative 2 plus 3 is 1. And that would be my answer. So we're going to work it that way. For 6, a little different. Remember, with these, we work inside out. So my first job here is to find g of 3, which basically just means that's my x value. So I go up to my g function. Wherever I see an x, I replace it with a 3. 3 squared is 9, minus 2 is 7. And then, okay, since I know that this value is now 7, I replace the g of 3 with 7 in the parentheses. And now I use my f function, and I plug the 7 in there. 4 times 7 is 28. Minus 3 is 25. So 2 steps there. Inner one first, get an answer. Work your way out to the one on the outside. Now, number 7, depending on when you see this, is something that we haven't currently worked on yet, but will be working on before the semester exam. So again, it depends on when you're seeing this. So consider the function f of x, remember, fancy way of saying y, equals 3x plus 3. Find the inverse function. Okay, reminder of how this works. Or maybe if you're seeing it for the first time, you're getting a little preview here. We're going to switch x and y. And then we're going to solve for y. So remember, f of x is just y, so we're literally going to replace it that way. So here's how this works. I'm going to switch the x and the y around. So x equals 3y plus 3. So notice they just changed places. But then I need to solve for y. I need to get y on a side by itself. So once you get that first step down, it's not too bad. So I'm going to minus my 3. Be careful. It's x minus 3, not negative 3x. I'm getting there. I got one step to go. That's to divide both sides by 3. So x minus 3 over 3 would be my f of negative 1 of x, again, which just means it's the inverse. Okay, that's kind of weird, but we can make that work. So then it says, graph the original function and its inverse in the coordinate plane. Okay. You can graph them on your own, or, if you so choose, you could go ahead, 3x plus 3. Now that I would hope you could graph on your own, but again, if you're kind of feeling stressed out, you need some assistance, you can always pull up your chart, start plotting some of those points that way. Okay, there's not going to be a reason on these that I can't be successful with it. So there's my first equation. So again, either I can look at my y-intercept and then go up 3 and over 1, or I can just use the chart. When I get to my second one, I have to be a little more careful. Okay, I've got to make sure with my x minus 3 that I have parentheses. And again, I'll look at the graph. Just looks like another line. It's just a little different of a direction. And what I do here is I don't like using decimals. So what I'll typically do is I'll go ahead, find the ones with whole numbers, and use those. Because when we draw an inverse, basically what I'm doing with all these coordinate points is I'm just flipping them. That's 0, 3. This is 3, 0. This is 1, 6. This is 6, 1. So if I didn't have a graphing calculator, but you will, I could do it that way too when I was going to graph. I could just take my initial line and flip all the coordinate points and make it work that way. But again, when we're on a test like this, might as well use the tools that we have. All right. Great. State the domain and range, then determine whether it's a function. Okay, domain, x values, left to right, forever left, forever right. Any parabola, that's going to be your domain. Range, y, bottom to top. Now, does it go up forever? It does. Positive infinity. Does it go down forever? Not quite. How low do we go? We go down to negative 5, and that's where we start. Bottom to top. Can't flip those. Can't put infinity to negative 5. That would be the opposite. And then the function, the last thing, remember, we're using the vertical line test. We're basically just going through here and saying, okay, anywhere I go, is there only one point of my graph that's going through my post-it note here, my vertical line? And as long as we pass that, that'd be yes. You're like, well, what would be an example of something that's not? Let's say I had something like this, and I had some funky curvy line like this. Okay? That wouldn't pass the vertical line test because there's multiple points on my graph. When I put my vertical line on here, or my post-it in this case, it would be that. So this would be a case of no, just in case something like that would come up. Just saying. Okay, I kind of remember this stuff. Oh, back to the applications. Travis throws a water bottle upward. The height of the bottle t seconds later is given by the equation. Complete the table below. Okay? Use the technology. So here, I'm going to go to my y equals. I'm going to type in my expression. Okay. And if they want me to complete a table, let me pull the table over here a little more. Time is always x. Height is always y. So we're given the x values. It's my job to plug in the y's. So I'm just going to copy them. So 106, 76, and 14. So that's pretty easy. So then it says, find the average rate of change air quote slope, because again it's not slope because it's not a line, in height from t equals 3 to t equals 4. So we do that by what's called the change in y over the change in x, which just means we're going to subtract them. So my y's, 3 is 106, 4 is 76. But then we say in the same order for seconds. 3 minus 4, 3 to 4. And when I go ahead and subtract these, and again, I could use the calculator, but if you do, just make sure you're using parentheses. It looks like at this point we're going downward, so my average rate of change would be negative. Okay, but we're just doing the change in x over the change in y. But again, we'll see some more practices with that. All right, CJ, graph the following absolute value function incorrectly. Okay, let's check this out first. Looking at this, what should my vertex be? Because remember, when we're doing these, now, do you have to write all this down? Maybe. If you want to see some things, you can. But here's where I'm kind of going to look in. So looking at this, it looks like it's the opposite of h is in here, and then k. So the opposite of 3 would be negative 3. But then that plus just means we keep what's out here. So my vertex should be at negative 3, negative 2. Uh-oh. CJ's is at 3, negative 2. Well, there's our problem. Negative 3, negative 2. And up 1 and over 1 each way. So how did CJ make an error here? Looks like we didn't do the opposite of h. In other words, CJ kept 3 as positive 3 and didn't make it negative 3. And you could even write that. CJ forgot to make the 3 negative or something like that. There's different ways you'd be able to write that. But I need to graph it. And again, remember with these, if my a value is 1, I just go up 1 and over 1 each way. And I can make my drawing. Because that one's a little trickier to play with in the calculator. So that one we just want to keep there. And it'll stay simple. I won't be throwing numbers in front of there and getting fancy on you. Okay? All right, let's keep flipping here. 11. Graph the following polynomial function. Identify any zeros. Show the end behavior. Okay? Again, we'll take our assistants, because we're good with the calculator here. Move that up a bit so we can actually see the expression. Okay, so we'll take a quick peek at the graph. And what we're going to do is, we're actually going to use the chart to help us make this graph a little bit more accurate. There we go. So any point that's on here that I can graph somewhat, I'm going to do. So 3, 12. Okay, 12's a little off, but not so bad. Negative 2, 0. Negative 1, negative 10. 0, negative 12. 1, 0. And then it gets crazy. So let me hit my graph again here. Oops, let me pull this back up for just a second here. Oh, I got some more points I could have used. Negative 6, 0. Negative 5 is like way up here. Okay, let me get the picture back. Okay, again, as you can see through my picture, your picture does not necessarily need to be perfect, but you can kind of see how this works. So when I go looking for the zeros, I could do a fancy thing on the calculator, but you know what I can do that's even better? If we use the chart, and we're going to look for places where y equals 0. Because any place that y is 0, that's where my intercepts are. And you even get a little hint here in with the number of blanks that there are. So I get those in and I'm good. And then end behavior, we've spoken about this before. As x approaches negative infinity, as x goes to the left, check out that arrow. What direction is it going? It's going down. Here's negative infinity. As x goes to positive infinity, as x goes to the right, which way is the arrow going? Looks like it's going up towards positive infinity. And I have that part. So hopefully most of this stuff, except for maybe the inverse one, should be a little bit familiar if you've done some of the things that we're doing in here. Okay, factoring, you had to know the algebra 2F word was coming. So multiply and add. Let's see here. What do I know? I know the multiply is a negative, which means it's one of each sign. I know the add number is negative, which means the negative number is bigger. So I need two numbers that multiply to 32 that are 14 apart because the signs are different. So if you start dividing numbers into your calculator,